Hello everyone! Today I'm going to show you how I set up my electrical network in my shipping container home. I will demonstrate the entire process of creating my electrical panel, connecting outlets, and my overall approach to designing the complete electrical network. My goal today is really for you to have the basics to understand how an electrical network works so that you too can do your installation at home. Alright, let's get started. Hi, I'm Julien and this is my house, container. I'm 26 years old, have no knowledge of do-it-yourself, but I've taken on the crazy challenge of building an eco-friendly and affordable house. I'm also trying to develop my resilience and live in harmony with nature. I'm filming and posting this on my channel, so subscribe to follow the adventure. I suggest we start with the central point of any electrical installation, that is the panel. The panel will consist of 4 required components. The technical housing duct, also called GTL. So it's this element that will allow to accommodate all the ducts and especially to accommodate the different panels. The 3 panels include the subscribers panel, which will host your linking meter, if not already outside, and your subscriber's circuit breaker. The electrical panel, which will allow to distribute the current through all your devices in your house via divisional circuit breakers. And then the 3rd panel is the communication panel, in which you will have your fiber arrivals, your telecom arrivals, your internet box. There you have it, that's the communication part. These 4 elements I was saying, which are mandatory, are according to the NFC 1500 standard, which governs electrical installations. I've put it in the video description for you. For those who are interested, all these elements are in the Schneider Ray C9 range. It's a very interesting range because it's not too expensive and at the same time it's super easy to assemble. Even without do-it-yourself knowledge, you can easily make your own electrical panel. I will explain in a bit more detail how each of these panels works. Let's start with the subscriber panel because it's the simplest. You can install the linky either inside your home, as I mentioned earlier, or outside in your electrical box. An Edis will choose for you. You won't have much choice. And then, here, you will have your subscriber's circuit breaker. There. You will need to size your circuit breaker. You have some that go from 15 to 60 amperes. It's depending on the power of your electrical installation. You have all the information on the board that appears on the screen. It's quite simple. Then you have the electrical panel, and for us to understand a bit better how all this works, I'm going to remove the door. With the panel now bare, we have a better understanding of how this all works. And we see that an electrical panel is composed of 2 main elements, differential breakers and divisional breakers. These divisional breakers, they will come to power each device in our house. To know which divisional breaker to use for whichever device, we refer to the NFC 1500. For example, it is customary to use 10 ampere breakers for lights and 16 or 20 ampere breakers for power outlets. Also, for example, for a microwave oven, it's going to be 20 amperes. For a fridge, it's going to be 20 amperes as well. If you now want to calculate more precisely what power you need, it's simple. You just need to multiply the amperes by the volts. So, for example, we have a 16 ampere circuit breaker on 230 volts. That will give us 16 times 230, 3,680 watts. So, I could put devices with a power of 3,680 watts on this circuit breaker. Be careful though, because even if, for example, you have an oven that only uses 3,000 watts and you think it won't trip the breaker. 16 amps, yes, but the NFC 1500 still advises you. I can't quite tell if it's friendly advice or if it's like, hey, they're advising you to use the 20 amps. I think it's in case the next occupant of this house has a more powerful oven than yours. It still needs to be adaptable to all uses. So, there you have it. You can calculate the power you need, but also pay attention to the recommendations of the NFC 1500. And now I'm going to quickly show you why I chose the resonant circuit breakers. That means it's unbrushable. Because normally, on an electrical panel, your circuit breakers, they are screwed in. Then your electrical cables that go into your circuit breakers are the same. They are screwed in. A panel, it's a lot of screwing, and it takes a lot of time. It's not necessarily ultra reliable compared to especially this technology, which is Ambros cables. So Resinef XE, I'm going to show you here. I want to add an additional circuit breaker. I just have to come and skewer it, snap and hop, it's good. I have an additional circuit breaker and then my electrical wires. I just have to clip them in, nothing to screw, It's done very, very quickly. That's why I chose this technology. It costs a few more euros, but in reality, it saves, I think, several hours of assembly. Now that I've shown you a bit about how all the divisional circuit breakers work, I'm going to show you how the differential circuit breakers work, which are at the beginning of each line and allow them to be powered. These differential circuit breakers. There are two categories, alternating current, or A, the alternating current differential circuit breakers. It's for all the common devices. And the A, it's reserved for everything that is cooking plates, electric cars, and washing machines. You see me, I put my 3 on the right line, so normally it's good. This is all regulated in the NFC standard 1500. In fact, in this standard, it indicates that on an electrical panel, there must be at least one alternating current differential and one A differential. To be able to precisely put your washing machine, your hob, all that on the right differential. So now you know which differential to choose between the alternating current or the A. You'll also need to know the power to take. On my panel, for instance, I have either 40 or 63 amperes. For that, it's simple. You will come to add up the powers of all your divisional circuit breakers of the line, divide the whole by 2, and it will give you the power you need for your differential. This rule, like all French rules, it contains 3 exceptions. The water heater, the heat pump, and the electric car. You do not divide by 2 because it uses a lot of energy. So in fact, the calculation method is different. I will give you an example on one line. You will understand much more easily. Let's take the first line of my electrical panel. We have a differential of 63 amps. On it, I have a 32 amp breaker for my heat pump. As I told you before, the heat pump is an exception. We don't divide by 2. Then I have two 20 amp breakers for my outlets. So there we can divide by 2, and then two 10 amp breakers for my lights. Same there, we can divide by 2. That gives me a total of 62A, 32A plus 10 plus 10 plus 5 plus 5. My differential of 63A is therefore well sized. And the last 2 mandatory elements on your electric table, it's going to be a lightning rod. It depends on the regions, but in reality, it's always better if you have it. Which is connected to your earth bar? Earth bar that will be connected to the ground outside, which I'll show you later. And the second element, it's a socket block with the associated circuit breaker. That's also mandatory, there you go, to have sockets on your panel. All of this is mandatory according to the NFC standard. 1500. Why do I insist so much on this standard? Why? Is it very important to respect it? Well, first of all, for safety reasons. And also because, since you're going to do your own work, you will have to call on a consul at the end of your construction site. This consul, he will come, he will check that everything is up to standard, and he will validate or not your installation. Only from that moment can you activate your subscriber's external circuit breaker and power your network. For example, the consul has not passed, so I don't have any power. So everything you see in this video, you don't need to leave a comment. It's not a big deal. I'm not going to die. There's no electricity. When you go through a professional, there's no need to have a consul inspection at the end, because generally the professional has an automatic consul, you know. It's assumed that since it's a pro, there's no need for someone to come and check. So it results in installations that are much less pretty than mine. I say this in a totally objective way. No, but really, check on your installations, have fun calculating the power of your differential circuit breaker compared to your divisional circuit breakers. I showed you before how to make it the right power. And often the pros, they kind of guess where they say it's fine, we don't care. And often the sum of your circuit breakers exceeds your differential. This video may upset electricians, but I've noticed this issue in numerous professional installations. It's less up to standard than me because I do pay a lot of attention because of the consul. But there you go. That was the little aside. There you go. Last little piece of advice regarding the electrical panel first. Buy a pre-assembled one. There you go. You're going to save a lot of time, and in addition, it's cheaper to buy it pre-assembled than to buy all the elements separately. That's why it's very important before you start your electrical project to make a diagram to know what your needs are in terms of circuit breakers. I, for example, had this diagram that you see on the screen, which allowed me to know exactly what I needed, and then to find a prefabricated panel that would almost exactly meet my needs. I added 1 or 2 circuit breakers here and there thanks to the plug inside. It was very quick, but there you go, it was really the most cost effective. This video is not sponsored by Schneider. But I find that their system, the XE egg resin, makes everything very, very convenient. And what I love is that we can add little doors for a low finish, very clean in the end, so I'm very happy with this installation like this. Now that our hub, our nerve center of the electrical network, is finished, it's time to connect each device to our different circuit breakers. But just before, I'm going to connect this electrical panel to the ground. Here we see that all devices are connected to the earth terminal, but this earth terminal needs to be connected to the ground. And for that, I'm going to use a 16 diameter electrical wire, which I'm going to run through a sheath under my container. And on the other side, I go back up into a waterproof junction box in which I have put an earth cutoff strip. You see, I have my ground wire coming in on the right and on the left. I come out with a copper wire, so a copper wire like that which I have buried in the ground, and which comes here to attach to a ground stake that I drove into the ground. So there, it's 1.50 meters. Which means that if there's an electrical problem on my network, instead of getting shocked, the electricity will take the shortest path. That is to say, it will exit from this ground bar and go along this stake into the ground. Now, our electrical panel is ready to be connected to our various devices and to pull the wires from each circuit breaker to each electrical point. We're going to use pre-wired conduits. Pre-wired conduits are recommended because buying conduits and wires separately is not cost-effective. It's the same price, but you're going to lose a lot of time, so buy pre-wired conduits. For the 10A circuit breakers, we're going to buy 16mm conduits, in which we'll have 3 1-5 wires. On the 16 and 20A circuit breakers, we're going to use 20mm conduits, with 3 2.5 wires. And on the 32A circuit breakers, we'll have 6mm wires in a 32 conduit. To know where I was going to put each electrical point, I first established a precise plan. Via COSICASA, knowing the locations of all my devices, power outlets and light points. Speaking of light points, stop lighting your house at random, stop putting recessed spotlights all over the house. It looks like a hospital, it's not pretty. You see here all the ducts that come down from my electrical panel and to route them to each of my devices. In my house, I came to create trenches in my insulation with a router and a suitable cutter in each of the trenches. I came to clip my ducts. Sometimes I put 2 ducts, one on top of the other. I was careful not to cut too much into my insulation to avoid creating thermal bridges. But there you have it. It's like a subway map. I came to serve my whole house. And on top of that, I'm going to put some waterproof tape to make sure there are no sealing problems. And I will come and finish with my parquet directly on top, and that will be good. My ducts run through my slices all over my house, and in some places they go up into plasterboard walls in my partitions between my rooms. So you can imagine that you have your duct inside. And I just came to make a hole in my plasterboard. I put a recessed box that allows me to accommodate my electrical wires. I connect this to a recessed socket and then it's very easy. The full tutorial is in the video description. That's really not the most complicated part of the job, you know? In places without plasterboard partitions, where I kept the metal of my containers for aesthetic reasons. Well, I couldn't recess my sockets, so I decided to install surface-mounted sockets. The principle remains the same for both surface-mounted and recessed sockets. Basically, we have our first conduit coming from our electrical panel, which goes into our trunking or our recessed box. Then, we're going to cut our conduit to leave the wires exposed, and we're going to strip the ends of our wires. So, with a little tool like this, we have the copper exposed, and this allows us to connect these wires to our electrical outlet. We follow the blue, white, red order since we are French. And then we will come out of the socket with 3 other wires that go back into another sheath, and that will go to power the other sockets of this circuit, according to the NFC 1500. On a 16A circuit breaker, you can bridge up to 8 power outlets, and on a 20A circuit breaker, you can bridge up to 12. Technically, it would have been possible to put recessed outlets on my shipping container. I would have just had to run my ducts outside my house, between my insulation and my container walls. Create a recessed outlet box, similar to those in plasterboard walls. But that would have caused two issues. First, I'd have to drill the containers, compromising their waterproofing, which is unfortunate. And in addition, use conduits that each time have to go all around the house to power all the outlets. That would have made me use a lot more electrical wire than going through the interior insulation, where it's much shorter, much more direct. I also took advantage of the specificity of my house, which is that the two containers bring me this little element there between the two to run my ducts for my lighting. So you see, it will go through. It will be hidden between my two containers. And then it will come out in small ducts that will supply each light point. Everything is already specified with small yellow tapes. I like it to be visual to understand where each element will be. The NFC 1500 also requires you to put RJ405 sockets to distribute the fiber in your house. Depending on the size of your dwelling, you will have a minimum mandatory number of sockets. In my case, I was required to install 4 RJ45 sockets. I started from my communication box, where I have RJ45 cables waiting. These cables pass through green conduits 20 millimeters in diameter, green to clearly identify that it will be fiber. I then brought that to my various points. Be careful, 1 cable per socket is forbidden to bridge, otherwise you divide the bandwidth. I'm going to remove the protective sheath, being very careful not to cut the wires underneath. And then I'm going to place these 8 colored wires in the slots with the associated colors. It's quite intuitive. We close the plug, it allows to make the contact, we cut off what exceeds, and we're good. For a detailed tutorial, check the video description. Now you know how to create an electrical panel, run conduits, and connect various outlets like RJ45 and electrical ones. Anyway, I've really put a lot of tutorials in the description to go into more detail on all these elements. Now, all that's left is to connect the indoor electrical panel to our outdoor electrical box to have power in our house. I'm going to show you all this outside. Come with me. If your land is serviced, you should find on the edge an electrical box that has been installed beforehand and that allows to power your home. If this is not the case, you will need to call Enidis and ask to service your land by installing a box, connecting it to an electrical pole. And all this, it's going to cost you about 1,300 euros. Before installing this box, consider burying 2 ducts, a 1.5 inches diameter green one and a 2.5 inches red one, which will go from your box to your electrical panel. In the green duct, you will be able to pass the fiber, and in the red duct, you will be able to pass the electrical current. In fact, for the electrical current, you will need to think about buying a cable of twice 16 millimeters. It's a very large cable, and to pass it through the red duct, to connect your outdoor meter to your indoor meter. And for the fiber, it will be your internet provider who will come and who will pull a fiber cable, a network cable that will enter your home. Once all that is done, you will be able to get the console inside your house, which will validate or not your installation. And then here, you will be able to directly activate your subscriber's circuit breaker. The link will be activated remotely. And that's it, you have electricity. And we finish with the part that you love in these videos. I'll explain everything, how long it took, if I struggled, and most importantly, the cost, and if I went broke. First of all, let's start with the time. It was a project where calculating the time I spent on it was difficult, because just planning everything that was needed, that is to say, watching dozens of tutorials, harassing the sellers, Leroy Merlin to understand how an electrical network works, buying all the equipment, buying the tools, laying colored tapes on the ground to make my entire page of my network. Finally, all this preparation, it already took me at least a good 10 days. And then it took me a day to dig all the trenches and put the ducts inside. A day to connect all the outlets, a day to do the electrical panel, even two. Sometimes I had help from electrician friends, thanks. In summary, considering all the finishing touches, the entire process took me around 20 days to complete. But compared to other projects, like framing or insulation, which are very intense, this one is not as demanding. But over very few days there, electricity, it's more diffuse. In fact, we always have a little switch. Added, a small sheath passed somewhere again, so the time is a bit more diffuse. So now let's move on to how much all this cost me. And here I take out my phone, because there's a budget in all this. For the electrical panel part, we have 100 euros for the GTL, 50 euros for subscriber boxes with door. 100 euros for subscriber circuit breakers, 560 euros for the electrical panel with the door. 60 euros for additional divisional circuit breaker. 100 euros for lightning arrestor. 30 euros for plug block for panel. 100 euros for communication box with door. The total cost for electrical wires, cables, outlets, and other components amounts to 1,100 euros. We have 150 euros of cables twice 16 to power the subscriber's circuit breaker. 150 euros of cables. 3x6 for the heat pump, the hob, and the electric car. 170 euros of pre-wired ducts in 3G, 2.5 for the sockets. 100 of pre-wired ducts in 0.1058, 203 ounces, 1.5 for lights, 80 of pre-wired fiber ducts. 170 euros for sockets, 30 euros for junction and embedding box, 50 euros to connect the panels to the ground, and that's all that. That gives me a total of 900 euros. The total cost for the electricity site is around 2,000 euros, although I may have overlooked a few items in my calculation. I bought many conduit outlets but returned them as they weren't right. I eventually wanted to change. In the end, I didn't count all the tools, although we don't need many. It's an additional 10-30 euros each time. Overall, my budget is around 2,000 euros. In conclusion, this electrical work was rather simple to carry out. Then again, I say that, but I haven't really finished 100%. After tackling so many complex tasks on this house, everything else feels relatively simple now. But finally, the two most complicated things I had to deal with were, firstly, the NFC. 1500. In fact, you won't find a portable document format online that explains the contents of this standard. It will only be summaries made by manufacturers. The documents I described, like Legrand's summary of his understanding of the NFC 1500, are in the description. However, it may not always be current or accurate. So it's quite scary when you think that the consul will come to your house afterwards and you don't have very precise instructions. It should normally work out. I'll update you on Instagram. And the second difficulty I had to face is that, once again, I'm in a container house, so I have to adapt everything I do. I had to find ways to route my ducts through the insulation by making trenches with a router. I had to consider how to position my outlets to stand out, how to glue outlets to walls to avoid creating thermal bridges instead of screwing them in. Things like that, that's the biggest difficulty. It's always the standards and the container house that makes everything different, actually. But there you have it. I hope this video has still allowed you to understand broadly how an electrical network works. Once you have this introductory understanding, you can watch all the videos I've included in the descriptions to learn more. Each step of this project concretely. Anyway, I hope you enjoyed it, that you appreciated my electrical installation. Do not hesitate to share this video around you and, above all, to support us financially. On Tipeee, if you can, or by calling on our association ETK Productions for the realization of your audiovisual projects. Same, or check the video description for details. Thank you for watching this until the end. I'll see you soon for upcoming projects, even though we're reaching the end. This was Julien. Goodbye.